Welcome class 10th. Today we are going to start our new chapter, that is surface area and volumes. So as already we have studied this chapter in class 9th, where we have gone through total surface areas, lateral surface area or curved surface area and volume of solids. What is difference here that we will study the total surface area and volumes and CSA of combined figures, and we are going to use same formulas which we have used in our class 9th. So first of all, our solid is cuboid. As we know, the TSA of cuboid, that is 2 into LB plus BH plus HL. See students, whenever it is written surface area, it always means total surface area. Okay, so be sure and remember this thing. So in cuboid we know there are 6 surfaces, right? And each surface is a rectangle. As you see in the figure here, each surface is a rectangle, right? That's why we are having this. This is first surface, then behind one will be the second one, then upper one is third, then the down one is fourth, and then the left side is fifth, and then this one is sixth surface. So 6 surfaces, each of one is a rectangle. So total surface area means the area of the sum of the areas of each surface. So that is, it is 2 into LB plus BH plus HL square units, right? And LSA of a cuboid, LSA of a cuboid means lateral surface area of cuboid, which is also known as area of 4 walls. So in this one, the top and the bottom will be not there, only 4 walls will be there, 4 sides will be there. So that is 2 into L plus B into H square units. And if you want to find the diagonal of a cuboid, the length of the diagonal of the cuboid, so that will be square root of L square plus B square plus H square. Okay, and the volume of the cuboid is length into breadth into height, cubic unit. Okay, same like this, if you go for cube, so in a cube also there are 6 surfaces and each surface is a square, means each side is equal. Okay, so you can we can see here there are 6 faces where each face is a square. So the total surface area of this cube is 6a square and the LSA is 4a square, and the diagonal is a root 3 and the volume is a cube. Then moving further, the next solid is a cylinder, which is also known as right circular cylinder. So here first of all we are going to see the CSA of the cylinder. CSA of a cylinder means curved surface area of the cylinder, that is 2 pi r h, right? If you see, then the total surface area of a cylinder, that is CSA of the cylinder, this is the CSA of the cylinder, and then the top and the bottom, if you add all these, then it will be the TSA of the cylinder. So 2 pi RH is the CSA plus the area of the top, that is a circle, that is pi r square, and the area of the base, that is also square, that is also a circle, that is also pi r square. So that is 2 pi RH plus 2 pi r square. So taking 2 pi r common, we can write it as 2 pi r multiply h plus r. and the volume of the cylinder is pi r square h, right? Now next one is right circular cone, that is right circular cone. Okay, so right circular cone we are having whose radius is r and whose height is h and whose slant height is l, So be very sure that there is a difference between height and slant height. Height is what? That is altitude that make 90 degree with the base, and slant height is tilted. Okay, so CSA of a cone is, that is pi RL, where L is square root of h square plus r square, where h is the height of the cone and r is the radius of the base of the cone. Total surface area, that is CSA of the cone plus area of base, and which if you see very carefully, the base is circular. So we will add the CSA and the base, that is pi r square. So that is pi rl plus pi r square. Taking pi r common, it is pi r l plus r. So that is the total surface area of the cone. And volume of cone is what? 1 by 3 pi r square h. Okay. Then next one is sphere. Okay, next solid is sphere. So this surface area of the sphere, or total surface area of a sphere, that is 4 pi r square. See, only we are having one face, so we say total surface area of the sphere is 4 pi r square, right? And the volume of the sphere is 4 upon 3 pi r cube, right? And if you go for hemisphere, if you cut a sphere into two equal parts, so each part is called a hemisphere. So you see, in a hemisphere we are having two faces, right? One is this upper one, which is a circular one, and this is then the down one portion. So CSA, curved surface area. So in curved surface area we have this portion. So total CSA of the hemisphere was 4 pi r square. So this is hemisphere. So the CSA of hemisphere is 2 pi r square. And the total surface area of a hemisphere will be CSA, that is 2 pi r square, plus area of the top, and area of the top is what? Circle. So the area of the circle is pi r square. So the TSA of a hemisphere is 3 pi r square, right? And the volume of a hemisphere is 2 by 3 pi r cube, right? And one more solid is there, which is frustum, which we will discuss afterwards, right? Then now let us go through our exercise, and let us start the exercise and see how to apply these formulas, right? Okay, let us move. So here is our exercise. Okay, so in the question, what is the question given here? Just a minute. Okay, so we are having our first question, that is two cubes each of volume 64 centimeter cube, volume is given 64 centimeter cube, are joined end to end. Find the surface area of the resulting cuboid. So we are having two cubes which are joined end to end. If you see very carefully, so how these cubes will be joined, this is our first cube, right? And the second cube is joined end to end like this. Okay, right? So our the second cube is joined like this. Okay, so end to end these are cubes are joined. So you see the width, because this is A. If we say the cube, suppose let us say that the side of the cube, edge of the cube is A, so height will be A, width will be A, and when we combined both the cubes together, so till here to here, this is A, and till here to here, this is also A. So total length will be 2A, right? So the combined figure will be what? So the combined figure will be a cuboid. The combined figure will be a cuboid, right? So let us say, now see, as we have assumed that our side is edge of the cube is A, and we know the volume of the cube, that is side cube or A cube. So we can say, according to the question, that is side cube, A cube is given 64. So the side will be cube root of the cube root of 64, that is 4 centimeters. So our side is 4 centimeter here. Okay, and the length of the resulting solid, that is our cuboid, right? So that is length will be 4 plus 4, that is 8 centimeter, twice of A. Breadth will be same, 4 centimeter, breadth will be same, and the height will be also same. And we need to find the surface area. Already I told you, whenever it is written surface area, it means total surface area. So that is 2 into LB plus BHL. 2 into LB plus BH plus HL. Putting the values, so we will have 2 into 8 multiply 4 plus 4 multiply 4 plus 4 multiply 8. Solving this, we will get 160 centimeter square. That is the total surface area of the combined figure, which is a cuboid, right? Okay. So while solving these questions, see, imagination is also very necessary. If you will imagine properly, then you can solve the question very easily, right? Okay, then moving to next question. So our next question is a vessel in the form of a hollow hemisphere mounted by a hollow cylinder. So what we are having? We are having a hollow hemisphere. So this is our hollow hemisphere, which is mounted by a hollow cylinder, right? So you see, we are having combination of figures, right? In first question also, it was the combination of two cubes. Here is the combination of a cylinder and a hemisphere. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. So we need to find the inner surface area. Okay, inner surface area of the vessel. Okay, so as the diameter of the hollow hemisphere is given 14 centimeter, so the radius is 7 centimeter. So you see, the total height is given 13 centimeter. Okay, out of which 7 centimeter is this one is 7 centimeter. So we can find the height of the cylinder, that will be 13 minus 7, so that is 6 centimeter, right? So you see, it is calculated here, that is 13 minus 7, that is 6 centimeter. Okay, sorry. Then now we need to calculate the inner surface area of the vessel. So the inner surface area of the vessel, that means total surface from the inner side, we need to find the total surface area. So that will be inner surface area of the cylinder plus inner surface area of the hemisphere, right? So inner surface area of the hollow hemisphere, inner surface area of the vessel will be inner surface area of the hollow sphere plus inner surface area of the hollow cylinder. Okay, and the surface area of hemisphere, that is 2 pi r square, and the surface area of the cylinder is 2 pi rh. Putting the values, sorry. Okay, as we have when we will put the values, of radius, that is one is 7 centimeter and height is 6 centimeter, we can find our answer, that is 572 centimeter square, and calculating, right? Question number 3. Once again we are having combination of, see what is it, a toy is the form of cone of radius 3.5 centimeter. You see this cone and the radius is given 3.5 centimeter, mounted on a hemisphere. The cone is mounted on a hemisphere of same radius, means the radius of the cone and the radius of the hemisphere is same, that is 3.5 centimeter. Okay, the total height of the toy is 15.5 centimeter. Total height is 15 centimeter, means from this point to this point it is given 15.5 centimeter, and from this point to this point it is 3.5 centimeter. So we can find the height of the cone, that is 15.5, that is 15.5, just a minute, that is 15.5 minus how much, 3.5, that is how much, 12 centimeters. So this is 12 centimeters, right? Okay, then as we need to find the total surface area of the toy. So total surface area of the toy will be what, that is CSA of cone plus CSA of hemisphere, and CSA of cone is pi RL, radius we are having L. L means slant height of the cone, and slant height of the cone is given by what, slant height of the cone, that is L, right, that is under root h square plus r square. Okay, that putting the values here, right, height of the cone is 12 centimeter and radius of the cone is 3.5. So calculating it, we got the slant height, that is L, that is 12.5 centimeter. So now the total surface area of the toy, will be CSA of hemisphere plus CSA of cone, 2 pi r square plus pi RL, right? So calculating it further, we got 68.25 pi, and by putting the value of pi we get 214.5 centimeter square, right? So enough for today. Okay.